Your computer is a crowded city. The CPU, GPU, and disk all speak different languages. Without the translator, the city stops. Today, we are demystifying Linux drivers. Your apps and hardwares are like people speaking different languages. They can't talk directly, so they need a translator. That's the driver. It takes an app's request, turns it into hardware language, and makes sure your computer actually follows order. But it's not just about languages, it's about safety. Your app lives in a user space. Think of it like a sandbox. You can play, but they can't touch the expensive stuffs. The hardware, however, lives in a kernel space. That's VIP vault. The kernel has absolute power over the machine, and there is a massive locked wall between them to keep the sandbox from breaking the vault. So how does an app cross the wall? Through a system call. When an app needs data, it triggers a software interrupt. The kernel stops everything, scans the request for security, and if everything looks good, it transforms that request into a privileged packet and lets it drop straight into the engine room. Here is the genius of Linux. Everything is a file. To the kernel, your mouse or your SSD is just a file in the dev folder. Each of these files has a major number. The kernel looks at that number like a GPS coordinate to find the right driver. It then maps standard commands like open, read, or write to the specific code inside the driver's brain. Now let's move some data. The driver grabs raw binary bits from the hardware and pulls them into the kernel. But remember, the app is still stuck in the sandbox. It can't see the kernel's memory. To fix this, the driver uses a secure bridge called copy to user. It's like a high security sliding drawer that safely passes the data across the wall into the app's hand. Hardware is painfully slow compared to your CPU. If the CPU waited for a disk to finish, your computer would freeze. Instead, the hardware zaps the CPU with an interrupt. The driver handles this in two parts, a lightning fast top half to acknowledge the hit and a bottom half that stays behind to do the heavy data processing while the CPU goes back to work. Almost every driver belongs to one of three families. Character drivers handles data byte by byte like your keyboard. Block drivers handles huge chunk of data like your hard drive. And network drivers, they are specialists. They handle high-speed data packets flying in from the internet. Finally, modern drivers are loadable modules. They plug in when needed with module init, sit idle waiting for work, and then leave cleanly with module exit. But watch out, if a developer forgot to clean up the memory, boom, kernel panics. The entire system crashes instantly. And that is the high-stakes world of Linux drivers. Thanks for watching. Subscribe for more deep dives in the system.